Hey, this is Mr. C, and this is Geometry Lesson 6, Yard Work Working in Segments. So, I invite you to try and go through these problems on your own, and then come back to this video if you get stuck anywhere. Um, and I also invite you, if you're going through the video, to pause and work on in sections. Um, work through as far as you can go and pause it, and then if you get stuck, come back to this video to get answers. Okay, so we have a yard work project going on, and we have some lines in which we're drawing to help us uh, figure out where to plant some stakes and some flowers and things like that. So we're not getting too into the complicatedness of this project. We're really going to be focusing on these lines. Okay? So our first scenario is Malik and his family are using the map to set up gardens and patios for the yard. They plan to lay out the yard with stakes and strings, shown as points and dotted lines on the map, so they know where to plant grass, flowers, or vegetables. They want to begin with a vegetable garden. They'll be parallel to the fence shown at the top. So, really, we have this segment here, and we have a stake set at -9, 6, and another stake at 310. And they want to mark the middle of this. They want to find where exactly is the middle point, okay, otherwise known as the midpoint. So, which we define as the halfway point of a segment, okay, or segment, or a point that divides a segment in half. Okay. So we have Malik. He's got an idea. He says it makes sense to me that the midpoint is going to be halfway over and halfway up. So he drew a right triangle and cut the horizontal side. So he drew this big right triangle, and then he cut the horizontal side in half and drew a line going up. And then he cut the vertical side in half, drew a line going this way, and he figures he's got the point marked. Okay, and he does. He does have that midpoint marked. And now he's got to figure out what that coordinate is. I mean, he could look and see where the coordinate is, but what he decides is that when he went halfway, he says that put me at right -3, 8. And the only thing that seems funny about that is that I know the base of the big triangle was 12 and the height of the triangle was 4. So I thought the midpoint would be 6, 2. So what's the problem with this logic? Okay. Well, first of all, 6, 2 um, is not the correct point. Okay. So I just want to advise you to take a little pause here and see if you can figure out why Malik is wrong. Okay, so what Malik has done, his geometry is good. It's just his coordinates. The reasoning of his coordinates is off. Okay, so this is a good strategy to find the midpoint. Okay, so we're kind of dividing the horizontal and vertical into separate parts. So if you look at what's happening with the vertical, it's almost like a rise and run sort of situation. He's going down grand total of 4 units, but if he cuts that in half, that's 2. Okay, so really he's going either up 2 from from 6, which would put him at 8 for the y coordinate, or he's going down 2 from 10, which is also 8. Okay, so it's kind of splitting the distance of that 4 into 2 and 2 to find the midpoint here. So the correct answer for the coordinate, or for the y coordinate, is 8, not 2. Okay. On the other side of it, the x coordinate, if you look at the total distance of the big triangle he has here on the horizontal, you go 2, 4, 6, 8, 10, 12 units. Okay? And half of that would be 6. So splitting that into 6 and 6. Okay. Well, 6 units to the right from -9 would be -3. Okay. So you did get the the distances right, but what he did for his coordinate is he put the halves, the distance of his halves. So we go 6 in the horizontal and 2 in the vertical, but that's not the coordinate. That's just how far he's traveling from the starting point. Okay. So I would explain that Malik used the distances to the midpoint as his coordinates. Instead of adding them from the starting point. Okay. So the 6, 2 is incorrect. That's how far he's traveling. He's going 6 to the right and up 2. So half of 12 and half of 4. Malik's sister Sapana looked at the drawing and said, "Hey, I drew the same picture, but I noticed that the 2 smaller triangles were congruent. Since I didn't know for sure what the midpoint was called, I called it XY. And then I used that point to write expression for the length of sides for a small triangle. For instance, I figured that the base of the lower triangle was x minus -9. Okay, so first what she's saying is that I know this point here is XY. I don't know, she didn't know exactly what the coordinates were. But from that point, she'd have to, with some x minus -9. So she's saying this lower triangle, the base of that is x minus -9. basically the distance here from, she's taking from this x to this coordinate here, and she's saying that's the distance. And then she's saying probably that this base here is also, you do similar strategy. And this would be x minus 10. Or sorry, minus 10, wrong coordinate. X minus 3. And then those two lengths would be equal. And we could solve that. So x minus negative 9, since those are congruent triangles. And x minus 3. So minus and minus is really a plus, so that's x plus 9. That's not exactly how it's going to work. Oh, I got it backwards, that's fine. X minus 3, it should be 3 minus x. So that becomes x plus 9. 3 minus x. So if I add x both sides, we'd have 2x here. Show that. Plus x plus x. And we have plus 9 equals 3. We will subtract 9, minus 9. And we have 2x equals negative 6. And then if I divide by 2, we get x equals negative 3, which was at our coordinate. It was, so that method works. Okay. And we could look at the y coordinates and see if that same strategy works. So that segment there would be y minus 6. And this segment here would be 10 minus y. Looking at our y coordinates here. So y minus 6 equals 10 minus y. If I add 6 to both sides, we'll end up with y equals 16 minus y plus y plus y. So then we'd get 2y equals 16. And whoops, button here. Divide by 2, and we get y equals 8. So that method did work. Okay. All right. So it's a little bit more algebraic. And we're kind of going to settle on a strategy that's kind of in between these two here. Okay. So both of them are kind of finding the halfway by finding half of the whole. But really, if we're trying to find a halfway point and we're in both of them break it into x's and y's. So the best way to do this is to find the halfway point between your x's and then find the halfway point between your y's. Okay, so for number 5, to find halfway between -3 and +2. Okay? There's two strategies you can use. I can look at the total distance and say from here to here is +5, so half of that is 2.5. So instead of adding +5, if I add half of that, add 2.5 from -3, my x-coordinate would be -0.5. So that's my x-coordinate. The y-coordinate, same thing. Going from 9 to 4. From 9 and 4, so that's subtracting 5. So we'll divide that by 2. So instead of going subtracting half, we'll subtract 2.5. And 9 minus 2.5 would be 6.5. There's a half of our y's. That's halfway between 4 and 9. Another way you can tackle this, so if we're trying to find the halfway point, is we could do the average. Okay, so we could add our two coordinates together and divide by 2. Okay, so I could take 2 plus -3 and divide that by 2. Okay, so 2 plus -3 is -1. Divide that by 2 and we get -0.5. So that is our x-coordinate. We could do the same thing for the y's. So 9 plus 4 divided by 2. So 9 plus 4 is 13. Divided by 2 gives us 6.5. So that's the same strategy. Okay. So I think I like this way better. Alright. Use either strategy to find the midpoint of the segment x1, y1, x2, y2. So really we're kind of coming up with a general formula for this, okay? So really a general formula, if we look at if we're taking the averages, we could add our x's together, so x1 plus x2, and divide by 2, and y1 plus y2 divided by 2. Or we could try to find the halfway point between x1 and x2 and the halfway point between y1 and y2. Okay. So number 7 gets a little bit more complicated. So the next area of the garden is marked for a flower garden. Malik's parents have the idea that part of the garden should contain a big rose bush and the rest of the garden will have smaller flowers like petunias. They want a section with other flowers to be. They want the section with the other flowers to be twice as long as the section of the rose bush. The stake on the endpoints of the garden will be at 1,5, so there's one stake, and the other endpoint is 411. So, Malak and Sapana need to figure out where the stake will be located if the rose bush will be closer to 1,5. So we want it 1 part to 2, okay, meaning that we really are dividing this into thirds rather than halfway. So I'd pause and let you see if you can figure this one out. And if you're back, so my strategy would be similar to what we've been doing. We're going to divide our big triangle, or sorry, our big segment into a big right triangle, like so. Basically dividing up our horizontal and our vertical. And for our horizontal, you notice that we have a length of 3 here, so I want to try and divide this into thirds, so that I have 1 part on one side and 2 parts on the other. So here's my division. So here's 1 part to 2 parts. And that horizontal will go up to where our partition point would be. Same with the Y's. We can see that this has a length of 6, starting at the lower end. If we divide that into thirds, each partition would be by 2. So if we want 1 part here, here's 1 part, then there's 2 parts on the vertical. So this is the division on the vertical side. And now we can see we're 1 unit from the left side, so 1 unit from to the right of 1, so my x-coordinate is going to be 2. And the y-coordinate, we're 2 units up from 5, so that is going to be 7 for the y-coordinate. And that's our answer. And we have 1 more stick to put in, and this time our ratio of parts is 2 to 3. So we have 2 parts on one side and 3 parts on the other. So really a total of 5 parts. And we're going to be starting so that our division of stake is closer to the -8, 5. So we're closer to this point here. So same thing, I'm going to divide this into horizontal and vertical segments here. On the horizontal side, we can count our units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all the way across is 10. And then I want to split that 10 into 5 total parts, which equals 2. So every 2 make a little partition there. Now what we wanted was a ratio of 2 to 3 parts. So 2 partitions on the left and then 3 partitions on the right. So we have, here's our first partition, there's our second partition, so there's 2 parts. Here's our division point, and then there's 3 on that part. So there is the horizontal coordinate. So grand total of 4 units from -8, or 4 units to the right of -8, which would be at -4. And then we're going to do the same thing for the vertical. So vertical goes down. So 5, 10, 15. If we take 15 divided into 5 total parts, each partition will be 3. So I'm going to split this every 3 units. 1, 2, 3, 1, 2, 3, 2, 3, 1, 2, 3. And now we have 2 units, oh sorry, we have 1 unit here. Sorry, 1 part here, 2 parts, so here's my 2 parts to 3 parts. And we're a grand total of 6 units down. So 6 units down from 5 would be -1. And that's our partition point, our stake point. So -4, -1. All right. We'll skip the ready for more for now. I'll give you the formula, but I think this method is a little bit easier than using the formula. Our takeaways are our midpoint rule. Easiest thing to do is take the average of the x's and the average of the y's. So x1 plus x2 divided by 2, that gets you your x coordinate. And y1 plus y2 divided by 2, that gives you your y coordinate. So there's your midpoint formula. If you are dividing not in half but some sort of ratio, the strategy is divide the horizontal and vertical parts into that ratio. If you need an actual rule, like an actual formula, this is the official rule, but I think the graphical method that we just looked at is a little bit easier. Okay. A couple of retrieval questions, and then we'll set you up with your homework. So, if we need to find the mean or the average of a set of numbers, the general rule is add the numbers together, or take the sum, and divide by the number of values. So, for example, number 1, we're going to add -5 plus 12 plus 32, and since there's 3 numbers, we'll divide all of those by 3. calculator. Do that. So -5 plus 12 plus 32. That gives us 39. Divide that by 3. And the average would be 13 for number 1. For number 2, we would take 3 plus 8 plus 14 plus 31. And since there's 4 numbers, we'll divide that by 4. 3 plus 8 plus 14 plus 31. That's 56. Divide by 4 gives us 14. Finding value that's exactly halfway between these two values. Well, halfway would be the average, so we can use the same tool that we've been doing. So do 5 plus 13 divided by 2, so that's 18 divided by 2, so that's 9. Okay. Or you can find the distance between these two and then find the half of that, so total distance between 5 and 13 is 8, and then half that would be 4, so that was another strategy you can use. So either way, I think I prefer the average, but especially a bit bigger numbers like number 4. So 2 plus 40 divided by 2, so that's 42 divided by 2, so the average would be 21. And then number 5, you pick whichever method you like. Explain why. Our last retrieval question is a proportion for side splitter that we've been doing. There's different proportions that you can set up. I'm just going to go with going top over bottom. So 2 over n equals 4 over 5, cross multiply, n times 4 is 4n, 5 times 2 is 10, divide by 4, and n equals 10/4, which can be simplified to 5 halves, or if you prefer a decimal, 2.5. So either of those answers. Okay. All right, your ready, set, go assignment is lesson 6. So you're going to do 2, 4, 6, 8, 10, 12. So the evens up to 12. And then 13 through 18. And that's your ready, set, go assignment.